Friday. This paper here just kind of also shows us some things that are good connections to make. If you look at the top, there's two equations up there. And so this is a system of equations if you have two or more. And what we're going to do is just remind ourselves that one of the ways to solve it is to graph it. So I'm going to go graph these first. If I have y equal x minus 2, oops, forgot to hit that. If I have y equal x minus 2, I know that my y-intercept is negative 2, so I'm going to go down here and color it in. And my slope is what on that one? Y equal x minus 2. What's the slope? 1. Yeah, up 1 over 1. So, going to be hard to do on the iPad. Let's see if I can't get it going. Something like this. Now I got another one to solve. It's 2x, and another one to graph. It's 2x plus y is 10. And if I, come on, I picked a bigger one because so it would work. Okay, so if I want to solve for y, all I have to do on this one is subtract 2x from both sides so I could graph it a little easier. And I get y is negative 2x plus 10. Come on, kick in there. All right, so that's got a y-intercept of 10. Let me graph it in purple or something so it'll show up better. So 10 is up here. That's that y-intercept, and it's like, if I looked at the slope, I could say it's down 2 to the right 1, couldn't I? If I stick that over 1, I could count down 2 to the right 1, down 2 to the right 1, down 2 to the right 1, down 2 to the right 1. Doesn't it look like they're crossing right there at that last dot I made, which is a little misshapen? That would be the solution, and it looks like that solution is happening if I can guess at 4, 2 is what I think the solution is. Now, if we don't graph really accurately, it can be hard to see, and if you have utensils that don't graph really precisely, it's also hard. So it's hard for me to see it on here. By the way, I want to show you something. What does this mean that it's a solution? If I came in here and I filled in this chart, if I put y equal x minus 2 in this column of this table, if I plug in 0, what's the y that goes with 0? 0 minus 2 is negative 2. 1 minus 2 is negative 1. 2 minus 2 is 0. 3 minus 2 is 1. 4 minus 2 is 2, huh? I am just filling in this table. We have two equations, so I'm just going to fill in the table. I'm just trying to show you something that you won't get quizzed or anything over, but it's just good for reference, okay? 5 minus 2 is 3, and 6 minus 2 is 4. That was that top equation. The bottom equation, this one right here, let's plug in the numbers to it and get the points. These are my x's, and I'm putting my y's over here, okay? This is what it would look like in the calculator. If you put these in the calculator and you looked at the table, you would see it. It would look like this. They give you the same x's to plug in, and they would list the y's in these columns. So this is what a graphing calculator would kind of show you. If I plug in 0, negative 2 times 0 is 0, plus 10 is 10. If I plug in 1, negative 2 times 1 is negative 2, plus 10 is 8. If I plug in 2, negative 2 times 2 is negative 4, plus 10 is 6. If I plug in 3, negative 2 times 3 is negative 6, plus 10 is 4. Doesn't it look like it's just counting down by 2's over there? Isn't that the pattern? So let's just count that by 2's there. So that would be 4, 2, 0, negative 2. I could plug all those in, but once I see the pattern, I can kind of, just follow the pattern once I've got enough to make sure that it's the right one. So on that column, if you can't read that green because it is kind of bright, it's 10, 8, 6, 4, 2, 0, negative 2. When you're solving, when you're finding your solution, you're looking for the point that's on both lines. Can you see right here it is? If I plug in x is 4 in the first equation, I get 2. If I plug x is 4 in the second equation, I get 2. Isn't that the point where they're both the same? You could look at a table, and this is how that I wouldn't be surprised on your SATs. Y'all's SAT changes, you know, you get the new one. And because of the trends in math right now, this could very well be an SAT test question. They could say, what's the solution to the problem represented by this table? Well, it's the point they have in common. And since they're giving you x is 4 on both of them, do you see how you get 4, 2, and 4, 2? That's the solution right there. You could tell it from a table. Our book doesn't approach it that way, but I just wanted to show you that's a possibility. They could be asking you to look. You're just looking for where the y value is the same, given the same x. Okay, though, so graphing's how we did it. We can just see from a table that we could maybe even tell the answer from a table. But really our new stuff today is this substitution method here. So let's go look at that now. I'll move to a new slide. Let me paste. Okay, straighten. Alrighty, so here's what we're going to do when we do substitution. When you're doing substitution, you're looking for one of the variables to be by itself. And if it's not that way, you make it that way. So this page has one that's already set up for you. You see how you've got this y equal x minus 2? Y is by itself. In this equation, is it by itself in the other equation? No. So this is set up as a classic kind of substitution problem. When I look at y equal x minus 2, isn't that telling me that y is the same thing as x minus 2? Right? If it's the same thing, couldn't we substitute it in an equation? Because they're equal amounts, I can put that in place of y. It's like this. If you're out and you're on a team, whether it's baseball, basketball, volleyball, whatever your sport is, football, if a coach has a player that's tired, he can pull that player out and put another player in to do the same job, right? That's really what substitution is. It's taking something out and putting something that will do the same job in its place. When you put something in, it has to be equal to what you took out in math. So if I think of it that way, if I look at this 2x plus 10, 2x plus y is 10, I am going to pull y out right here, this plus y, and I'm going to stick this in its place because it's the same thing. So that's going to be 2x plus, instead of y, in its place, I'm going to put x minus 2 because they're equal, so I can use it instead of y. And then I got to put my equal 10. I'm taking this equation and I'm using it in the other equation. I'll do some more of these, but this is kind of a good intro problem. If you look now, you've only got one variable, and that makes you able to solve the problem. If you have 2x plus x, what's that going to be? That's 2x plus x is 3x, right? You have 3x minus 2 is 10. So I could solve for x now. I could say, okay, I want to get x by itself. I'll add 2 to both sides. That would give me 3x equal, come on, stupid thing, 3x is equal to 12. And if I divide both sides by 3, what is x going to be equal to? Hey, we knew that already because we graphed it and saw that was the solution. We actually saw it in the table also, didn't we? So this is kind of like we're finding the answer now, and this is the third way we found it because we've already done those two lower parts here. If x is 4, does that tell me the whole answer, though? My answer is a point. What does a point have? It has a x and a y, so I need the y that goes with it. I could plug this x into either equation and get the answer, but wouldn't it be easier if I plugged it into this one? Because I want to know the y, and that says y equal. If I plug it in, I know now that x is 4, so I'll plug in x. And I'm going to subtract the 2 out because the equation is x minus 2. So 4 minus 2 is 2. I know my answer is x is 4, y is 2. That's how substitution works. You take out something and replace it with an equal amount so that you just get one variable. Once you get one variable, you can solve and find that variable. And then you take that and you plug it into something into one of the equations to find the other variable that you don't have. We'll work some more of these. This is kind of an idea of basically how this goes.